right, this is the fourth FRQ from the 2014 AB exam. So first, they asked you to find the average acceleration. Notice here they did not say the average value of acceleration. That would tell us to use an integral. But when they say the average acceleration and the table gave us velocity, that means they want us to find the average rate of change of velocity. That's acceleration. Average rate of change is just the slope. So they want the slope from 2 to 8. So I'm going to say velocity of 8 minus velocity of 2 over 8 minus 2. So that's negative 120 minus 100 over 6. Negative 220 over 6 is negative 110. Oops. 110 over 3. And then for our units, we're doing the units of the y divided by the units of the x. So we have meters per minute divided by minutes. Meters per minute divided by minutes. It looks like they didn't say that you needed the units though. But the answer would have been negative 110 over 3 meters per minute squared. All right, part B. Does the data in the table support the conclusion that the train's velocity is negative sometime between 5 and 8? So we're looking for a specific value. We're not looking for a specific rate of change. Since we're looking for a specific value, that means we're looking at the intermediate value theorem. So the velocity at 8 is negative 120. The velocity at 5 is 40. So I'm going to say the negative 100, sorry, should have turned that off, is somewhere in between the velocity of 8 and the velocity of 5. And so since 100 is in between those two values, and they said that this is a differentiable function, if it's differentiable, that means it's continuous, then by the intermediate value theorem, there has to be negative 100 is the velocity. So I'm going to say v of t is differentiable, and therefore is continuous on 5, 8. So by the intermediate value theorem, there exists some c on the closed, the interval 5, 8 such that the velocity evaluated at c is negative 100. Okay. Question C. Time equals 2. The train's position is 300 meters east of origin station, and the train is moving to the east. Integral that gives the position of the train at the time t equals 12. So I'm going to say at 2, not the velocity, the position. The position at 2 is 300 meters east, and they want me to figure out what the position is at t equals 12. So I'm going to say the position at 2 plus the integral from 2 to 12 is what would give me the position at 12. Okay. And then I say to use the trapezoidal sum with 3 subintervals. So position at 2 is 300 plus 1/2. 3 subintervals going from 2 to 12. So the first subinterval goes from 2 to 5. And that would be 100 300 plus 40. Then from 5 to 8. Then from 8 to 12. Okay, and then they want to approximate the position of the train. I think in this one you could still leave it like this. You'll have to look at the scoring guide. But we'll go ahead and simplify it down anyway. I'd be careful with this one. So 1/2 times 3 times 140. 1/2 times 3 times -80. 1/2 times 4, -270. 1/2 times 3, 140 is 60. 2 times -270. 1/2 of 60 is 30. So we've got 300 plus 90 minus 540. 390 minus 540 is -150. So it looks like the position of the train is 150 meters west. So -150 or 150 meters west. Okay. They did not say necessarily that you had to interpret the position in context. I don't know. Both of those answers are probably good. Okay. Part C says a second train, train B, travels north from origin station. At time t, the velocity of train B is given by that function. At time 2, the train is 400 meters north. Find the rate in meters per minute at which the distance between A and B is changing. Okay, so train B is 400 meters north. At t equals 2, we know that train A is 300 meters east. So for D, we've got a triangle. We've got this train is 300 meters east, 400 meters north. They want to know at what rate this distance is changing. So I can see this is a Pythagorean triple, 3, 4, 5 triangle. So at this exact moment in time, they must be 500 meters apart. And I'll go ahead and call this X, this Y, and this is Z. I'll say X is 300, Z is 500, Y is 400. The rate that this is increasing is what we are trying to find. Dx dt, so that's the velocity that this train is going, which is train A. So the velocity that that train is going is 100. Okay. Dy dt is the velocity of train B, and to do that we have to look at the velocity of train B at time t equals 2. So that's -5 times 2 squared plus 60 times 2 plus 25. So -20 plus 120 plus 25, 125. Okay. So we have a right triangle. We're talking about side lengths and rates of change of those side lengths. So I've got x squared plus y squared equals z squared. And when I take the derivative of all of that, I have 2x dx dt plus 2y dy dt equals 2z dz dt. And so I've got 2 times 300 times 100, 2 times 400 times 125, 2 times 500 dz dt. So 2 times 3 times 1 is 6 with 4 zeros after it. 125 times 4 is 500. Oh, that's a bad way of doing it. Okay, 500 plus 2 zeros. There we go. And then that would be 10 and 4 zeros. 1, 2, 3, 4. How'd you like that math in my head? The other way you could have done it is 2 times 125 is 250. And then 250 times 400. Okay, so that equals 2 times 5 is 10, 2 zeros. Okay, so we've got 100,000, 60,000 is 160,000. Divide by 1,000, we get 160. And the rate of change is going to be the same as the velocity for all of these problems, which was meters per minute. So we're going to say the distance is increasing because they're going away from each other, and this number is positive, is increasing by 160 meters per minute.